My name is Jamie Cope. I am the Manager of Business Development at the WVU Industrial Extension. I want to welcome everybody. Thanks for joining us for the webinar today. Just a few housekeeping rules before we get started. This will be recorded, and at the hopefully early next week, you'll get a copy of the recording and the slide deck so that you can have that and review it. Feel free to share it. We have more webinars coming up. Greg will be telling you about that here in just a minute. We would love for this to be interactive. So if you've got any questions, go ahead and put those in the chat. If we don't get to them during the presentation, we'll definitely try to get to all of those at the end. So be saving up some good questions for Greg. I'm sure he'll appreciate that. If he doesn't know the answer, he'll know somebody who can get the answer for you. So we're just happy to have everybody here at to join us for this. And don't forget to check out wvmep.com/webinars with an S to check out the things that are coming up. We've got a lot of really cool things, manufacturing roundtables, more safety things. We got a very specific one on wood coming up next week. So with all that being said, I'm going to just turn it over to Greg and let you run with it, buddy.
All right, thank you, Jamie. And thanks everybody for stopping by and checking out this webinar. We'll put together some slides, and we want to talk a little bit about what a dust hazard analysis is. And just going to do a general overview. We want to get you the basics so we know what we're talking about when you're out in the industry. As Jamie was saying, we do have a couple more webinars coming up on April 7th. It's the CMMC NIST 800 171 compliance process. And then on April 8th, the wood product manufacturing, John Fraser, creating a compliance list for the top 10 MFC standards. And all webinars run from 11 to 12, unless noted, and they are free of charge. So stop by. All right, the West Virginia University Industrial Extension partners with small and medium-sized manufacturers in West Virginia to support operational improvement and business growth. As part of WVU, the IE serves the university's mission, land grant mission, and is housed in the Statler College of Engineering and Mineral Resources. As West Virginia's affiliate to the NIST MEP National Network, the West Virginia University Industrial Extension is part of a nationwide program of centers tasked with supporting the manufacturing community. This unique arrangement provides the industrial extension the opportunity to support the manufacturing community from a national, state, and local level. The WVU IE focuses on developing consulting services that reflect client needs, provide hands-on education, and work one-on-one with our clients to deliver practical solutions in the areas of workforce, occupational health and safety, management systems, operational improvement, advanced manufacturing, leadership development, and innovation and growth services. So let's get started with what we're all here to learn. Welcome to this webinar titled Dust Hazard Analysis. We will discuss the basics of a dust explosion and how to protect your employees and business if you have explosive dust in the work area. Before we get started, I want to address a few housekeeping items. At the end of the presentation, there will be a Q&A session. If you would like to submit a question, please use the chat box as we go. And finally, make sure your devices are muted. My name is Greg Green. I'm a safety and health specialist here at the WVU Industrial Extension. I have a master's degree in safety and environmental management from WVU and over 15 years of field experience with 12 years as a federal coal mine inspector with the Mine Safety and Health Administration. I have traveled with MSHA in West Virginia, Ohio, Colorado, Illinois, and Texas, and I spent my early career with Kiwa Corporation as a safety manager working on projects in Atlanta, Georgia, Omaha, Nebraska, Portland, Oregon, and San Diego, California. So enough about me, let's get started. All right, the objectives for today's webinar will be discussing what is flammable and explosive dust, identifying areas that produce explosive dust, and how to implement controls to prevent dust from accumulating. this initial case study shows a combustible wood dust explosion and fire that injured a worker at the Inferno Wood Pellet Incorporated. OSHA cited Inferno for 11 serious violations of workplace safety standards and has proposed $43,400 in fines related to the August 20th incident that partly demolished the building. According to OSHA, the explosion was ignited by wood dust in the wood pellet plant's production room that migrated to a retention bin. The force of the explosion threw the injured worker 20 feet. He was treated for first and second degree burns. While no one was killed, the potential for death and serious injury was real, present, and preventable. OSHA said the lack of safeguards allowed the initial fire and explosion to occur and spread in a chain reaction to other equipment and through the plant. If this employer had adhered to applicable OSHA and National Fire Protection Association standards, that would have helped prevented the fire and explosion from occurring and spreading. OSHA said its investigating of Inferno Wood Pellets plant found accumulations of combustible wood dust on various locations and surfaces within the plant. Employees were exposed to wood dust explosions, deflagrations, or rapid combustions, and other fire hazards. Among other hazards, the dust retention bin lacked spark detection, explosion and fire suppression devices, and explosion venting systems. In addition, OSHA said the dust collection systems and dust segregation barriers were not maintained to minimize fire sources, and an opening in the wall between the production room and the chip room allowed the fireball to spread. Let's take a quick poll to get started. Does your work environment produce dust? All right, very good. 83% says yes. So this is definitely going to be a good webinar for you. All right, so what is a dust hazard analysis? A DHA, as they're referred to, is a systematic review of the processes and areas of your facility where combustion particulate solids are present. The analysis will help identify the fire, flash fire, and explosion hazards that exist in your facility. In short, if you have a combustible dust and it creates a fire or an explosion hazard, you need to have a dust hazard analysis. So what is combustible dust? It is any combustible material that can burn rapidly when in a finely divided form. If such a dust is suspended in air in the right concentration, under certain conditions, it can become explosible. Even materials that do not burn in large pieces, such as aluminum or iron, given the proper conditions, can be explosible in dust form. So you'll hear the term often, what is deflagration? It is often used to describe combustible dust explosions. A deflagration is an ordinary fire, such as a gas stove, burning wood or paper, and even the burning of gasoline vapor inside the cylinder of an automobile. In a deflagration, a burning substance releases heat, hot gases, and energetic particles or sparks that ignite and spread the fire. In a dust explosion, the deflagration process happens so rapidly that the heated air and gaseous fire products, such as carbon dioxide, produce extreme air pressure that can blow out walls and destroy structures. So how do explosions happen? Any fire needs three elements. These elements are known as a fire triangle: fuel to burn, oxygen, and an ignition source, such as heat or spark. A dust explosion needs two additional elements. This is known as the dust pentagon: dispersion of the dust particles in the right concentration and confinement of the dust cloud. Dispersion means the dust particles are suspended in the air. Confinement means the dust is in an enclosed or limited space. This restriction allows pressure to build up, increasing the likelihood of an explosion. So what are the basic requirements for a dust explosion? For the basic requirements for a dust explosion to occur is that combustible dusts are suspended in the air and are ignited. In practice, for a dust explosion to occur, a number of conditions must be met, including the dust must be combustible and release enough heat when it burns to sustain the fire. The dust must be capable of being suspended in air. The dust must have a particle size capable of spreading the flame. The concentration of the dust suspension must be within the explosible range, and the ignition source must be in contact with the dust suspension. The atmosphere must contain sufficient oxygen to support and sustain combustion, and there is a form of confinement or enclosures that allows pressure to build. What is primary and secondary dust explosions? Well, primary and secondary dust explosions occur when combustible dusts ignite. There are often two explosions, known as primary and secondary. The primary dust explosion is the first explosion. It occurs when there is a dust suspension in a confined space, such as a container, a room, or a piece of equipment, that is ignited and explodes. The primary explosion will shake other dust that has accumulated. When that dust becomes airborne, it also ignites. This secondary dust explosion is often more destructive than the primary one. This illustration depicts the primary explosion as the blast waves heat and the flame moves through the area, kicking up the dust, adding fuel, causing a secondary explosion. As you can see in the illustration, the initial blast would kick up this dust, which would be located on top of piping, floors, machinery. That dust cloud would form, then it would ignite, causing the secondary explosion. So who is affected? A wide variety of materials that can be explosible in dust form exist in many industries. Examples of these materials include candy, sugar, spice, starch, flour, feed, grain, tobacco, plastics, wood, paper, pulp, rubber, pesticides, pharmaceuticals, dyes, coal, and metals such as aluminum, chromium, iron, magnesium, and zinc. These materials are used in a wide range of industries and processes such as agricultural, chemical manufacturing, pharmaceutical production, furniture, textiles, fossil fuel power generation, recycling operations, and metalworking and processing, which includes additive manufacturing and 3D printing. There are many variables that must be considered when identifying a combustible dust hazard. The particle size of the dust, the method of dispersion, ventilation system characteristics, air currents, ignition sources, confinement of the dust cloud, physical barriers, and so on. As a result, the often quoted rule of thumb about dust accumulation, such as being able to write in the dust, or the dust being the thickness of a paperclip, dime, or quarter, or the amount of visibility through a dust cloud, is not always reliable. Have you researched if the dust present at your facility is combustible? Are there documented cases reported in literature about the materials in your workplace being associated with a combustible dust explosion? It is very important to research the materials and products used in your workplace. Stating the possibility of a combustible dust hazard is a requirement on the safety data sheets. Testing of the dust can be done through independent labs that will analyze your dust to determine the combustibility. Do you manufacture or use any materials in their byproducts that can become a dust? Do you have a process such as abrasive blasting, cutting, grinding, sieving, polishing, cleaning, or other tasks that can create dust? Let's look at some engineering and administrative controls to prevent a fire or explosion. Dust collectors. Use an appropriate dust extraction and collection system with the inlet located as close to the dust producing process as possible. Follow required standards and codes when installing these systems. Locate those dust collectors outdoors where possible. Do not use brooms or compressed air hoses to clean surfaces. Use only vacuums approved for dust collection. Use a dust collection dust extraction system that is designed to eliminate or control combustible dust. Use appropriate electrical and ventilation equipment. Select and use intrinsically safe tools or machinery. Using most models of fans typically stir the dust, adding dust particles into the air and worsening the situation. Keep all mechanical and electrical equipment in good repair. Check equipment that may wear, such as bearings, as they may generate heat and become an ignition source. Put covers around pipes and cables, or embed those pipes and cables in the walls where possible to reduce surfaces where the dust can accumulate. Keep static electricity under control, which includes the bonding and grounding of equipment. Check all bonded and grounded equipment regularly to ensure the bonds are in good condition. Do you have ignition sources such as sparks, fires, flames, stoves, kilns, or welding flames? Can dust enter or accumulate on electrical enclosures or equipment? Does your workplace have a no smoking policy? Are there measures to isolate smoking and ignition sources away from production areas? And always remove open flame, sparks, friction, heat sources, and other sources of ignition when you can. Now let's look at some administrative controls. Developing and implementing a combustible dust inspection and control program which outlines how often inspections will occur and how dust will be controlled. Establish a housekeeping program that will remove dust regularly. Use proper equipment and techniques when cleaning dust. Care must be taken to minimize dust clouds and only use vacuums approved for dust collection. Develop a hot work permit system for activities such as welding and cutting. Develop an ignition control program to eliminate or reduce sources of ignition. Keep ignition sources away from dusty areas or use suitable controls. Educate all employees about combustible dust, the hazards, and how they can eliminate the risks of fire and explosions. Use proper equipment and techniques when cleaning dust. Care must be taken to minimize dust clouds and only use vacuums approved for dust collection. Regularly inspect machines, ducts, and ventilation systems for dust, and always repair or clean them promptly. So let's take another quick poll. Do you have a cleanup plan or a program at your work location? All right, very good. 76% have a plan in place. Make sure that plan is written and your employees are trained on that, and definitely keep the documentation or you can produce that at a later date. All right, let's get into the meat and potatoes. Dust hazard analysis. Do you need one? All right, test or not to test. First, you need to determine if your dust is combustible. Collect the dust and send it to a certified independent lab to be analyzed. If the sample comes back combustible, then a DHA is required. If it comes back non-combustible, keep that record on file to show proof that the dust is not combustible and no DHA is needed. If you know or assume that dust is combustible, a test is not necessary, but a DHA is required. So what can OSHA cite? OSHA can cite the general duty clause for not having a DHA if a fire or explosion occurs at your facility. They will reference the NFPA 652 standards or any other standards applicable under NFPA that reflects your industry, such as metal, grain, pharmaceuticals, etc. NFPA 652 explicitly states a DHA is required for all new processes and facility compartments going forward. However, the standard provides September 7th, 2020 as a deadline to ensure a DHA is completed for existing processes and facility compartments. DHAs must be performed by a qualified person and reviewed and updated every 5 years. NFPA defines combustible dust as a finely divided combustible particulate solid presenting a flash fire hazard or explosion hazard when suspended in the air or the process-specific oxidizing medium over a range of concentrations. In layman's terms, any fine material, dust, with the potential to catch fire and explode when mixed with air. Examples of possible combustible dust include wood, powdered metals, plastics, rubber, chemical dust, textiles, sugar, and grains. NFPA 652 states organizations with possible combustible dust hazards need to do the following. Determine the combustibility and explosibility hazards of the materials. Identify and assess any fire, flash fire, and explosion hazards. Manage the identified fire, flash fire, and explosion hazards, and communicate the hazards to affected personnel. These expectations are somewhat different than the previous NFPA 652 requirements because they apply to existing processes. Before, existing processes were most exempt from these requirements. So what can you do to help comply with NFPA 652 or other NFPA standards? Develop and implement a combustible dust inspection and control program which outlines how often inspections will occur and how dust will be controlled. Develop a hot work permit system for activities such as welding and cutting. Develop an ignition control program to eliminate or reduce sources of ignition. Keep ignition sources away from dusty areas or use suitable controls. And educate all employees about combustible dust, the hazards, and how they can eliminate the risk of fire and explosions. Inspect for dust at regular intervals. Establish a housekeeping program that will remove dust regularly. Use proper equipment and techniques when cleaning dust. Care must be taken to minimize dust clouds and only use vacuums approved for dust collection. Regularly inspect machines, ducts, and ventilation systems for dust and repair and clean promptly. In summary, start by having your dust analyzed or assume it is combustible. Get a dust hazard analysis performed by a qualified person now and every 5 years. Next, plan on eliminating and cleaning up combustible dust in your work environment. Protect your employees and business by implementing good housekeeping procedures, fire prevention measures, maintenance of equipment, and removal of combustible dust. Here's a basic checklist for combustible dust. So you can ask yourself, do we have a dust hazard analysis? Do you know what types of combustible dust your facility has? Does your facility have a housekeeping plan? Features a cleaning plan for surfaces where dust accumulates, such as floors, pipes, ducts, ledges, and beams. Is dust on the floors or other surfaces? Are they removed during regular inspections? Is smoking only allowed in specified safe areas, and areas where smoking is prohibited are clearly marked with no smoking signs? And does your company use methods such as grounding and bonding to dissipate static electricity? And finally, are safety data sheets for chemicals that could become combustible under normal operations available for employees to consult? Thank you for attending, and I hope you picked up some good information that will help you in your facility. Do you have any questions?
Yeah, Greg, that was great stuff. Thanks so much for that. I learned a lot. I know that. So anybody who has questions, go ahead and feel free to put those in the chat. And I do have a few here as well. When you mentioned a couple of times during your presentation that one of the things to do is to educate your employees. Do you have any suggestions about how that happens or when that happens? Is that a production meeting, or how does when would you say is when and how is the best way to educate?
Yeah, very good question. There's a couple ways you can do that. One, if it's a new employee when they're going through the first initial phase of hiring, and two, those could be general safety topics and safety meetings. They can be done weekly, monthly, annually, just to make. I think education is the best part, the most important part in a factory setting, to know that these guys are working with materials that could become potentially explosive, and making sure that they know the precautions that they need to take to protect not only themselves but also the employees and the business.
Sure. Oh, and here's a good one. You mentioned research materials for combustibility. Where can that be done? Do you have any suggestions on, because I know personally, whenever I listened to the list, it was like, okay, wood dust makes sense, but some of those things I wouldn't think were combustible. Where can we check?
Yeah, another good question. The best place to go would be your manufacturer of the product that you're using. You can go to the National Chemical Safety Board. Their NFPA is another good resource. There's a lot of different entities out there. One of the main things is, if you are on the fence that if it is combustible or not, would be to get an independent company, a third party, to analyze your dust. And it's not a huge expense. They initially charge you, a lot of the places will initially charge you for a go, no go test. So if it is explosive, they go on to the next phase, which usually in my experience is maybe under a couple $1,000. That will tell you exactly what, if your dust is explosive, and it'll give you more insight to protecting your assets.
Okay, great. Here's another one. If OSHA visits your facility, would they look for dust accumulation? And if so, is there a chance of being cited if there's a lot of dust accumulation?
Yeah, I'm going to put my inspector hat on, and it varies on the inspector's background. If the inspector doesn't have a lot of background in explosive dust, they may not catch on to that. But it seems to be that it's going to be a major, not a major, but it's a focal point now with OSHA, because after October, I think it was October 2020, that they're going to be looking for these things. So if you say you're operating a cabinet factory and you do have a lot of explosive or wood dust, wood shavings, sanding, there's probably a good possibility that he's going to ask you, hey, do you have a dust hazard analysis, and what is your housekeeping program for this? And it's almost like a Pandora's box. Once they start digging, they may not stop. But if you can produce this information for them, say, hey, here's my dust hazard analysis, this is what we're doing, this is how we comply. Or you can say, hey, here's my testing of my materials, it's not explosive. And then all is good.
Okay, great. Would using a non-explosion proof vacuum for small cleanups create a risk of explosion internal to the vacuum?
If the material is if it's not explosive, there
It's a
should not be any.
non-explosion proof vacuum. Could using a non-explosion proof vacuum for small cleanups create a risk of explosion internal to the vacuum?
That's a good question. If you're just going to Home Depot and buying a shop vac and you're sucking up, it all depends on the material that you're cleaning up.
Okay.
If the material is combustible, you need to have an intrinsically safe vacuum system. And I've mentioned that a few times in the program. The concern with non-intrinsically safe products, such as just a Home Depot vacuum or a Lowe's vacuum, is that those combustible particles can get into the internal electrical components. So when you turn that vacuum on, it creates a spark and could create an explosion. So yes, the main goal is to see what material that you're cleaning up, is it safe or explosive? That's the key right there. And then you can determine on what type of equipment you can use to clean up.
Okay. Okay. Do we have any other questions from folks out there?
I just want to hit on when I say intrinsically safe, that means that this material, the electrical enclosures, are permitted to be used in explosive atmospheres. So initially, what intrinsically safe means is that it will allow an explosion to occur inside that box, but it's designed to dissipate the heat out of the box, not allowing the box to explode, but that heat will escape. Once it's escaping, it's not hot enough to ignite the outside either vapors or explosive content or explosive atmosphere. So it's kind of a unique situation. It's used in mining system. We call it a permissibility, but yes, we allow the explosion to occur inside that intrinsically safe box, but the box is not destroyed and it dissipates the heat. So when it reaches the internal or the external atmosphere, it's not hot enough to ignite the explosive atmosphere.
Okay. Okay, great, great. I don't see any more questions coming through. So I'm just going to thank everybody for coming, and thank you, Greg, for another great presentation. That was really good stuff. And you've got Greg's contact information there. If you have any questions that you think of as soon as we hop off of here, be sure and just reach out to him or reach out to any of us at the Industrial Extension. We're always happy to talk to folks. So yeah, again, thanks everybody for coming, and we'll send a recording out later next week or early next week.
Thanks, everybody.
Yeah, thank you.